as he is our expert speaker today. And once I finish with his introduction, then I'll hand over the session to him, and he can continue with his expert talks. All right. So Mr. Satish Jethwani is the chartered engineer, member of IEI, and he is a gold medalist in civil engineering. Almost carrying 80 years of experience in structured design of power plants, material handling, as well as oil and gas structures. He is having enriched experience working with various MNCs. He has worked with L&T for 8 years, India Engineering for 6 years. He has been working as a coach for the engineering students, and currently he is the director and training head at EZ Engineers Private Limited. He has not only worked in India but with other countries like Germany and Saudi Arabia as well. So Mr. Satish Jethwani, we welcome you again, and we look forward for your expert delivery of talks on the subject that we have shared with you. Sir, I hand over the session to you. Please take over. Thank you.
Thank you very much. I will try my best so that the student gets maximum benefit of industrial exposure. Okay, I will show you a few softwares which they may be using in the future, and they can make their career better. Okay, and I will share some technical material too. Okay, let's start. I'm sharing one video with you. Through this video, I would like to explain you what is the importance of structural engineering. Okay, in industries, even a small mistake can cause a big failure. Okay, so I will show you small video. Let's see again. I will show you one more video. Now I am sharing you video of steel structure. Let me share. Okay, friends, these are the few failures which happen due to slight mistake, maybe in construction, maybe in execution, maybe in structure design. That's how our work is. It's literally like the work of surgeon. Even the surgeon of brain, surgeon of heart, you can understand if he makes one mistake, if he makes one small mistake, what can happen to the patient. So similarly, friends, if we make a small mistake, not only a single patient, but lots and lots of people, lives of lots and lots of people can be affected with that small mistake. Okay? So we have to understand that it's literally very, very, very responsible work, literally like surgery. Okay. We have to understand everything with very conceptual knowledge along with mathematical knowledge. Being only mathematically good is not the enough thing which is required for structure engineering. I will again share with you a small video of 2-3 minutes in which I will try to explain you how to understand a small thing with conceptually. In this, I'm going to explain you about what is center of gravity. This you may have learned in the first or second semester of your college, in BE or even in diploma also. Okay, let's see that. If you go to vegetable market, the person is giving you vegetables holding like this. He put some vegetables here in some weight. What we think, if the weight is 5 kg, that means the vegetables are 5 kg. Okay? But actually it is not like that. Understand? Now that person is holding this weight. Say, yes, put some weight here, and the vegetables what you are buying is here. Okay. So if it is showing you level, that doesn't mean this is 5 kg, that means this is also 5 kg. But that means moment about this point, moment of this weight about this point is equal to the moment of this weight about this point. By chance, if this dimension is say 20 centimeter, and this dimension is say 18 centimeter. Okay. So if this is leveled, then this moment is same. That means actually you are getting, instead of 20, you are getting only 18. That means you are getting 10% less vegetables. So when this load is 5 kg, this will be say 4.5 kg only, and still it will show you. Okay. So the basic point what we need to understand is center of gravity is not the center of area, but it is the axis about which moment of that area, moment of this weight becomes equal. Okay friends, so I think now you understand that how we can learn the things conceptually. Go to vegetable market. Okay. Now I will show you actually when we are working for an industrial project, how the workflow will happen. It will not be as casual when we are working for a residential project. Okay. When we are working for an industrial project, we need to have proper input, proper specification, proper geotechnical reports. Okay, so I will show you few of the sample projects which our company has done. I have available few drawings. So I will show you that so that you can have clear exposure, which you will be actually working on those kind of projects after a few years. Okay, let's start. First of all, I will show you which document we need for starting of our structure design. Okay. Give me a second to open that document. See friends, this is the document which I will receive at the starting of the project to design. Okay. So this input is prepared by a mechanical engineer or equipment engineer. They have given me the requirement of their factory, how the plan will be there, how the elevation will be there, what type of equipments will be supported. Once they give me this input, okay, see this is the cross section of the building. This is the cross section of the building. So based on this, I will prepare my layout part. Based on this, friends, based on this, I will decide what will be the location of bracing, what will be the location of column orientation, okay, what will be the support fixity direction, what will be the type of the connections. Based on all these concepts, I need to finalize my structure. That means say for example, this is the structure. The dimension of this industrial structures will be decided by mechanical or electrical person depending on the structure type. Size will not be decided by me. Size of the structure will not be decided by me as a structure engineer. Size of the column and beam will be decided by me. Okay. Here, where we need to put beams, where we need to put more columns, whether the column orientation will be like this or like this, it will be decided by structure engineer. It cannot be decided by any of the software in the world. Understand friends, if you learn State Pro, if you learn ETAPS, if you learn SAP, in that you have to give this input. Where will be the bracings? That you have to decide as a structure engineer. You can model plan bracing, cross bracing, vertical bracings, knee bracings in the model, in the State Pro or ETAPS software. But where to model, that has to be decided by you only. Okay. So in software, we will model this. In software, we will model the type of the connection. There can be 20 types of connection which will be available in software like State Pro or ETAPS. But where to provide which type of connection, that can be decided only by you as a structure engineer. So if we don't have knowledge, if we don't have this conceptual knowledge, there is no meaning of learning the softwares. Okay. So first we have to collect this knowledge. Once this layout part is done, we can model this, all those things instead. We can model the connection types. We can model the column orientations, supports, and then we can analyze our structure. We can see what will be the deflection. We can see what will be the bending moment. We can design the structure too. What will be the size and all those things, depending on our layout part. Any software will not give you recommendation that this orientation is wrong and you should give this orientation. Software cannot give warning like that. Okay, software will just show whether it is pass or fail. Now once you are done with this, then you need to prepare rough sketches for your draftsman. Okay, I will show you simple rough sketches. Hold on. Okay friends, now I will show you how we will give this input after state pro to a draftsman. Okay, see friends, this kind of rough sketch will be prepared by a structure engineer. Okay, how much reinforcement is required, or in case of steel, in case of steel we can give input like this: base plate dimensions. Okay, this is ABCD written. What does it mean? Your engineer is written I will show you. Engineer is written, structure engineer, that what do you mean by ABCD? This is the member size and all. This we can get from State Pro. So this is called input to draftsman. Once you are given input to draftsman, what this person will do? That person will prepare drawings in AutoCAD or MicroStation based on your input. I will show you now those sample drawings. See friends, this is the drawing prepared in AutoCAD. Okay. This drawing is based on your input, based on the input of structure engineer. This drawing can be prepared in AutoCAD. This drawing will be prepared by a draftsman. Okay. The qualification required for this preparing this drawing is diploma or ITI. Of course, BE civil person can also do this. But for working as a structure engineer, you must have BE minimum. It is not necessary that for being structure engineer, you have to go for masters. Yes, of course, if you go for the masters, you will be a better structure engineer. Now I will show you the next stage of this procedure. Once these drawings are ready, this was a sample RCC drawing. I will show you a sample steel drawing also. See friends, this is a sample steel drawing. This all drawing belongs to a actual project. Okay, this drawing also can be prepared by a draftsman. Here the size of the members will be given by structure engineer. See, here it is written MC, that means this is moment connection. Okay, so where it will be moment connection, where it will be shear connection, that also will be mentioned by structure engineer. Based on that, the draftsman will prepare this type of drawings. But now friends, based on these drawings, we cannot do construction, we cannot do execution. For execution, we need one more stage. I will show you that. Friends, this is that stage which we need after steel structure drawing and before execution. This drawing is required for the execution purpose. In the previous drawing, we had just shown the member size, like this is MB450. But in this drawing, we will show all the details. We will show all the details pertaining to connection, cutting, bolt, holes, welding, all small details. Friends, this is called fabrication drawing. This is called fabrication drawing. Now, in this fabrication drawing, we need to show all the small details. These fabrication drawings can be prepared in AutoCAD also. But if we prepare those drawings in AutoCAD, suppose for a industrial structure, medium size industrial structure, it may take 2 months for the preparation of fabrication drawing in AutoCAD. Then the same structure fabrication drawing can be prepared in Tekla in just 10 days. Okay, I'm talking about the software Tekla. Okay, in Tekla we can prepare the fabrication drawings. How? We actually prepare 3D model in this, and then out of that 3D model we can fetch the fabrication drawing and it will generate the fabrication drawing automatically. These drawings can be opened in AutoCAD also. Then minor editing can be done at your site. Okay, I will show you a sample video for Tekla software.
mistakes caused by yesterday's. The undisputed solution is an arsenal of.
See friends, based on this model, this is the model prepared in Tekla. Based on this model, we can fetch the fabrication drawing. We can export a file which is called NC1, and it will look something like this.
DSTV, then imported into.
Here all details like weld marking, bolt location, cutting, everything is given. So this file can be directly now exported to CNC machine like this. This is the CNC machine.
For mid-sized to large structural fabricators looking to increase productivity and reduce labor costs. The Petty Writer CNC layout marking system is the high-capacity solution.
So this member will be automatically cut as per the requirement. So there will be no chances of mistake. Even the member number can be marked automatically. See like this.
Layout marking of structural shapes, such as beams, channels, angles, square or rectangular tubes, and flat bar. From welded connections to copes, the Petty Writer is the first layout machine of its kind.
So this can be done automatically. This is the magic of Tekla. Okay, friends, I would share with you the approximate price of the softwares. The AutoCAD software, we can purchase a license at about 20,000 rupees or so. The software like StadePro, eTapes, we can purchase at the price of about 2 lakh rupees. And the Tekla software, okay, the license of Tekla software, the cost of that is about 12 to 13 lakhs. Okay, so you can just imagine the amount required for the investment of this type of work. Okay, so the Tekla doesn't only help in the design part, detailing part, it literally helps in execution part also. AutoCAD helps you in drafting part. StadePro helps you in designing part. You may have heard BIM, okay, BIM modeling and all those things. Now BIM is not a separate software, my dear friends. Actually BIM is a kind of working, it's one platform. Whether you are working on Revit, whether you are working on Tekla, whether you are working on AutoCAD or StadePro, still you are a part of BIM. Okay, BIM means you put all your input at a single stage. For example, electrical person has modeled his cable trace, piping person has modeled the piping, and structure person has modeled his structure. Now I will put all those together and I need to see what will be the actual flow of the project, how it will be seen, whether there will be any interference, whether we can operate the valve or not. I will show you a sample view when we put all those things together. Okay, hold on, I will show you that. See friends, this here you can see the structure also, you can see the ladders also, you can see the equipments also, you can see the piping also, you can see few cable trays also. So this is kind of beam modeling what we are talking. The software StatePro will be used to design this. Tekla will be used to design to detail the connection part and model this physically. Piping softwares may be needed to model this pipe. Then again, stress analysis, piping stress analysis software will be used to analyze the stresses in this pipe. So BIM is actually not a single software, it's cluster of software. And nowadays majority softwares are done in such a way that they are compatible to BIM. So BIM, you don't, some candidates ask me, sir, I want to get training in BIM. It's not a separate software, my dear friends. If you are learning StatePro, so still you are a part of BIM. If you are learning Revit, you are still a part of BIM. If you are learning AutoCAD or Revit, you are still a part of BIM. Okay. Now this was for a steel part. For RCC, what drawing we had prepared. For RCC, like in steel, we prepared fabrication drawing. For RCC, we need rebar drawing, what we call BBS, bar bending schedule. I will show you a sample drawing. Let me open it. See friends, this is the sample of bar bending schedule. So once you have prepared the RCC drawing, you need to prepare a bar bending schedule where each and every detail of each and every bar will be shown. Okay. Based on this, cutting will be done. Based on this, bending will be done. And then we can execute further for the structure. Now friends, the most important part of this project and this work is to prepare the calculation report based on which your fabrication will be done, based on which your design drawings will be prepared, based on which bar bending schedule will be prepared. Okay, that is the core part of the structure design engineering, and very few engineers know that work. If you know that work, if you understand how to do that work, you can be a good structure engineer. You can have a wonderful career. I will show you that document. Hold on, I will show you that. See friends, this is that calculation report. in which we need to define each and every element, each and every calculation for bolt, weld. We need to define everything. We need to show all the calculations. Calculation for wind, calculation for geometry, calculation for seismic. Okay. See, wind pressure, all the loads. Okay. Based on this calculation only, you can finalize the size of the member, you can finalize the weld size, you can finalize the bolt numbers, the bolt diameter, the base plates. Without this calculation, we cannot submit our drawing, we cannot prepare our drawing. The site work cannot be done without this. This is the core requirement for a structure engineer. You need to show each and every small coefficient from the code. For example, for foundation, you need to show all the checks. Check for stability, check for overturning, check for sliding, check for base pressure. This is the state file input. Okay. This is from a live project at our office. We need to show each and every check. See, this is the deflection and this is the permissible deflection. So we need to show that our structure is safe in deflection, our structure is safe in bearing pressure, our structure is safe in bending moment, shear force, torsion, everything. And how you will get the bearing pressure? What is the permissible bearing pressure? I will show you. Hold on.
Satish.
Yeah.
Okay. Please continue. Yeah.
Yeah. Okay. So friends, this is the soil report of a particular project. In this, you will be given what will be the allowable pressure on the soil, what you must have learned in your bachelor's of engineering. What will be the net SPC? Okay, this will be given by a geotechnical person. Based on this, we will design the foundation sizes. Okay. So friends, this was the overall picture that how structure engineering work happens actually in an industrial structure. But for all this, you must have conceptual knowledge. Now I will share a small video again with you that how we can learn conceptually. Okay. In this video, I'm going to explain you a small connection detail. In books, we understand like this. Simply supported beam. Fixed beam. Okay, this what we learn in the book. Now I will show you how actually it happens at the site. How we need to learn as a structure engineer these simple things. Give me a minute, friend. I will share the video with you. friends, how are you? Welcome to my workshop on professional RCC structures, steel structure of beam. Yes friends, which is this beam and which is this beam? Type A and type B. Okay, can you tell me what is this? Yes everybody? Yes, you are right. This is simply supported beam and this one, yes, fixed beam. Now this we have learned in our academy, in our bachelor's and in our diplomas. Okay. Now, how this beam will get deflected when a load is applied at the center? For example, this, when we apply the load, the deflection will be something like this, and in this case, the deflection will be like this. Now, my question is, have you ever tried this, or you have just read from the book that for simply supported the deflection will be like this and for fixed beam the deflection will be like this? Have you ever tried? See, understand friends, all the times we don't need big laboratories and expensive material to try all these things. We can do this simple thing with even a simple scale. Would you like to see how? Let's see. Make all something. Please. See, here now we are applying load on this scale. Okay, can you apply with a finger please? See, friends, this is a deflection curve over. Now let's see for a fixed beam. Yes, slightly more. See, can you see the shape? Okay, let's make this shape more clear with the soft one. Okay, now please, this is simply supported, and now this one. See, can you see this shape? Exactly like this. Thank you. Now after looking at this shape, now can you tell me the picture what I am going to show you? Which beam is that? Whether it is a simply supported or fixed beam? Please have a look on this. Okay. Now, yeah. Tell me. Everybody, please. Yes. Can anybody tell me? Okay. Confusion? Whether it's a simply supported or fixed? See. Now, this is the problem. This we have covered in our academy. But the picture which I showed you, this is not covered in academy. This practical thing now, I will explain you friends. This is column, this is beam. Okay. Now, when this beam is getting deflected, for example, I draw the double line of this. This goes something like this, and in this case, everybody clear? So, let's see. Focus on this face. What happens? In simply supported, this face gets rotated. There is some theta. Whereas in the fixed one, this is not getting rotated. The theta is 0. Okay. Now, how can we achieve this? Let's see. For example, this is an I section beam, friends, and I am holding it from here. Okay. And let's see whether it gets rotated. Yes, of course, it is getting rotated. I mean, this face gets rotated like this. Okay. Say instead of 1 bolt, I provide 2 bolts. Okay. Yes, still gets rotated. Slightly lesser, but still gets rotated. Now, quite less, but still this face gets rotated. Okay. Now, how can we make it fixed? Let's do some magic. Okay, see the magic. It's not rotated now. It's not rotated. What we did? Yes, anybody? Simple thing. When we hold from the center, it gets rotated. But we hold from top and bottom. That is the simple logic. Now, if I see any connection, my dear friends, in this, if I provide a split angle with bolts in between. Okay, this can rotate because there is some space here, right? Now, many of the engineers think like that when we are providing weld, it is fixed. No, it has nothing to do with it. Even if you weld it here, this is simply supported only. See, whether we bolt or provide weld, it doesn't have any difference on simply supported or fixed. But where you are providing weld, where you are providing bolt, it has to take concern with this. Understand? If I provide bolt or weld, this beam can rotate. But if I provide a beam like this and say there is no space for rotation here, can you see this space, friend? Okay, I will see. I am talking about this space. I am talking about this. If there is a space, this can rotate. So that will be simply supported. But if there is no space or the space is filled with weld, okay, one option no space, another option you fill that space with the weld, or third option you provide the plates. In all these three cases, the connection will become fixed. Let's have again a look on this structure, on the beam which we show. Yes, can you see the space there at top and bottom? Yes. So now, which is this connection, everybody? Yes, you are right. It is simply supported. Now let's see one more picture. Yes, can you see this? We can clearly see the weld is provided near the flanges. So there is no space at top and bottom. That means this connection is fixed connection. Everybody clear about this? Though there is a space near the wave, but there is no space near the flanges. That's why this connection is fixed. Now you see any connection, whether at railway station, bridges, at sheds, factories, and you can quickly identify which is this connection. Am I right, dear friends? Okay. Now, which this connection simply supported, actually in industrial language we call this simply supported as shear connection. Okay, and this one we call